Okay, so we'll start our class. So in the last class, we were talking that we finished this geological history of. So that part we'll finish in the second part. First, we'll finish the motions of the earth. Then after that, if we have time, we'll study that one. Otherwise, we'll study geological history of the earth in tomorrow classes. Okay. Okay, so we'll start our classes now. Hi, good evening everyone once again. So in today classes, we are going to study about the motions of the earth. Okay, like motions of the earth, why it is necessary to study. Like in day-to-day life, we are seeing that we have the day and night changes. Okay, we have day, we have night. Sometimes it is happening, sun is setting before itself. Like we have the night for the shorter times during the summer season. Day we have the longer time. Then we have the seasonal changes. We have some seasonal changes. So all these things, it is occurring because of these particular motions of the earth. So in today classes, we are going to study regarding the motions of the earth. So in the motions of the earth, like how we know in our day-to-day activity, motions means what? Movement. Like we have for ourselves, like if we do some movement, so that we call it as motion. So similarly, our earth is also moving. Okay, so that is what that so that they are moving in a like various manners. So in that case, we have the rotation and the revolution. So in our today classes, we are going to study about the rotation of the earth, and we are going to study about the revolution of the earth. And also we will see that all those phenomena occurring because of the rotation and the revolutions of the earth. So we will see everything on this part. So now first we will study about the rotation of the earth. Now in this rotation of the earth, we know that suppose a person is rotating on this particular place. Suppose here we have the land. Okay. At this particular place, if person is rotating here itself. Okay. So that will be what? That will be the rotation. That will be known as what? Rotation. Suppose if person is there. Okay. And here we have like how you all would have seen the horse riding. Okay. So in that case, what is happening? Like they will be moving in a circular manner. In the horse riding, if you see, so they are like they're adding horses in the circular manner. So that time what happens? Like some people are standing here. So in that case, that horse, what it is doing is revolving around this particular man. So that is the revolution. So similarly, in the case of the earth also, we have this particular part. Now we know that according to the definitions, when we study in our previous classes, we know that sun is at the center. Okay, sun is at the center of the solar system, and all other planets revolves around them. So similarly, we have our planet Earth, where life is possible. So this Earth, what it is doing? See, it is revolving around the sun. So now it is at this particular place. After a few days, it will be at this particular place. After a few days, it will come to this particular place. So that part is known as what? Revolution. But in this case, like suppose if Earth is here, okay, now Earth is here at this particular place. Now in this case, what is happening? What it is happening that Earth is we have this axis. Okay, now Earth is rotating on this axis itself. Okay, so that is what? That is the rotation. Okay, so the spinning movement of the Earth is called rotation. Means what? Spinning must rotate, moving on its axis. Okay, so if axis names comes, okay, so that will be what? That will be the rotation. And revolving is what? Revolving around the sun. So that will be the. So now in this case, we must know that the Earth rotates around its axis in west to east. Okay. So already we saw while studying about the planets, there we saw that all planets rotates west to east. Only two planets are there which rotates from east to west. That is Venus and the Uranus. Okay. So that part we have seen. Now in this, Earth's axis is the imaginary line. We already saw like we have the longitude, latitude. So it is what like this we have taken as a imaginary lines. Okay. So that is what happening that passes through the North Pole. So Earth center and the South Pole. So Earth axis, like suppose here it is rotating. So that axis will how it will be passing? It will be passing through. Suppose if you have this axis here. So here how it will be passing? Here we have the North Pole. Then we have the center. Then here we have the South Pole. Then Earth's axis is what? Antipodal. So that means what? It passes to the center of the Earth, connecting two exactly opposite ends. So that is what? That is the Earth. Our Earth's surface is what? It is antipodal. Okay. Now in this part, we must know that our Earth, when it rotates, on its axis, so how much time does it take to come to the similar place while rotating? So that rotation is what? Rotation of the Earth is how much? 23 hours, 56 minutes and 4 seconds. 23 hours, 56 minutes and 4 seconds. But what we are doing, approximately we are taking as the 24 hours. Okay. Where if regarding the revolution, if you see, revolution we have the 365 days and 6 hours. Okay. So that's why after 4 years, we are saying that will be the leap year, and in that leap year we have the 366 days. Why? Because the Earth is revolving around the Sun in 365 days and 6 hours. And after 4 years, this 6 hours, it becomes like 24 hours. Okay. So after 4 years, how much days we have? We have 366 days. And that's why we call that year as a leap year. Okay. So it takes approximately 24 hours. Okay. So 23 hours, 56 minutes and the 4 seconds to complete the one rotation. And regarding the rotation, we all must remember that the day and the nights occurs due to the rotation of the Earth. And how this particular process is happening, suppose if we all have doubt, day and nights, how occurrence is happening, that also we will see in this particular class. Now, the circle that divides the day from night on the globe is what called? It is called the circle of illumination. Okay. And we know that Earth is tilted. Okay. Earth is tilted or inclined. By how much degree it is tilted or inclined? It is inclined by 23.5 degree. Okay. 23.5 degree on its axis with the normal. So now in this particular point, now we'll see here. Now everyone see this diagram. Now in this diagram, can you all see, like if we draw this Earth, okay, we are studying that this is what? North Pole, South Pole. Okay. This is what? This we are taking it as what? Magnetic North Pole and South Pole. Okay, like imaginary. But really, if you see, according to the inclination, so what? Geographical north and south, how we have? We have lines. Okay. This will be what? Geographical north and the geographical south. So now in this particular point, see here, we saw that our Earth is tilted at 23.5 degree, or also we call it as the incline at 23.5 degree. Okay. Now regarding this particular point, you all must know that this line, okay, this line, if you see this equator, this is known as what? This is known as the orbital plane. Okay. This line is known as what? Orbital plane. Okay. And if we draw from the center of the Earth to 90 degree north, okay, to the 90 degree North Pole or the South Pole. So this line will be, this particular straight line will be known as what? It is the vertical plane. Okay. So in this case, this will be what? Vertical plane. Now regarding this inclination, how we are seeing? See, for this is important part, we all must remember. See what is happening. Here it is 90 degree. Okay. And here we have this particular geodesic equator. Now from the orbital plane, from this, like some questions might come. Okay. So in these questions, leave this particular, in these questions, like questions might come here like that our Earth is tilted on its axis by 23.5 degree. Okay. Otherwise, other questions, how it can be that Earth is tilted. Suppose if they change the language, Earth is tilted on its axis by how much degree on its orbital plane. Okay. So suppose if this question comes, orbital plane, if this question comes, see here how to answer it here. Now what is happening? That tiltness we are measuring from this particular point. while studying on the latitudes, we saw that this we are taking as a 0 degree, and from here we are measuring 1 degree, 2 degree, 3 lies we are measuring. But here regarding the tiltness, how we'll measure this tiltness? We are measuring from here. Okay, so from here, from this, now this will become the 0 degree. Now in this part, from the vertical plane, what it is happening, it will become the 0 degree. Okay, and from this 0 degree we are measuring. Okay, so from this 0 degree to 23.5 degree we have here. Okay, so from here to here we have this 23.5 degree gap. Okay, so this angle is how much? 23.5 degree. So this is what, this is the tiltness. Okay, it is tilted at 23.5 degree, and that is from the vertical plane. Now in this case, what is happening? Now since it is 23.5 degree, and also we know that if we measure from here, from the equator part, okay, so here we have the 90 degree. So, and this is the orbital plane. So now if questions comes regarding the orbital plane, so in this case, what you also do, we know that if we have to measure from here, so this is a 0 degree, and here according to the orbital plane, here this is the 90 degree. Okay, but whereas regarding the vertical plane, if you see, this becomes the 0 degree, and this will be the 90 degree. Okay, so if the questions comes regarding the orbital plane, so in this case, how we all must know that, see here we, from 0 to here we have the 90, and here we have this 23.5 degree. Okay, so what will be the angle? Okay, so what if they ask that how much it is tilted from the orbital plane? So what will be this angle? What will be the value of this particular angle? So already we know that here till here we have 23.5 degree. So can we minus 90 degree minus 23.5 degree? Okay, so how much will we get? We'll get 66.5 degree. Okay, so Earth is tilted on its axis by 66.5 degree on its orbital plane. Okay, that is on its orbital plane. Or if simply, if question is like this, Earth is tilted on its axis. If simply the question is like Earth is tilted on its axis, so that will be what? That will be 23, and that will be 23.5 degree. If simply question lies, if they have not mentioned the orbital plane or the vertical plane. Okay, if they have not mentioned this orbital plane or the vertical plane, then the answer will be 23.5 degree. If they are mentioning particularly as the orbital plane or the vertical plane, so if they are mentioning the vertical orbital plane, so in that case what happens? The degree changes, and that degree will be how much? That will be the 66.5 degree. Okay, remember this. And this 23.5 degree, it is from where? It is from the vertical plane. Okay, so this important point you all must remember, because from these questions have been asked. So remember this. And regarding this orbital plane, question was asked that at how much degree it is tilted from the orbital plane. Okay, so now according to the because of the rotations, what are all those phenomena happening on our Earth's surface? So remember, all we saw that our Earth rotates on its axis, completes one rotation by 24 hours. And it is tilted on its axis by 23.5 degree. Okay, already we saw this particular point also. Now in this point, you all must know that day and night changes happens because of the rotation. Okay, day and night changes happens because of the rotation, and the seasonal changes happens because of the revolution. So remember this particular point also, seasonal changes happens because of the revolution, and the day and the night changes happens because of the rotation. Day and night changes because of rotation. And questions, if questions comes regarding the seasonal changes, then this happens because of the revolution. Okay, so this important point you all must remember. Okay, so now in this particular point, see, in this particular point, now we'll move to the revolution. Then after that, we'll see that how all those things, this rotation and the revolution are happening. Okay, after that, we'll see. Now in this particular point, we all must remember that, see, we were seeing regarding this particular point, when we draw this particular circle. So in this case, what happens? Here, see, now here this particular line we have. Okay, that is the geographical north and south. Okay, now in this case, this line, if you see, this is what? This is the circle of illumination. Okay, here in this particular point, you can see here, this line is what? It is the circle of illumination. Okay, So this line is what? It is the circle of illumination. Okay. So this point we must remember. Why we must remember? Because how it is, like see, it is dividing this earth into two parts. Okay. Like here we have the light. Okay. And here we have the darkness. Okay. So that's why this particular line is what? It is the circle of illumination. So remember this particular point. Okay. We have a study regarding the circle of illumination. Now this particular day and night, these changes are happening. That is happening because of which season. So see here, in this we have this circle of illumination. We have this particular line. Okay. So now in this point, what happens? Here we have this particular geographical north and south. And now in that case, what happens? This becomes the equator. Okay. When we have this circle of, see, our earth is tilted on its axis. Now because of the tiltness, now what happens? Now this line becomes the equator. Equator won't be like this straight line. So now here, because of tiltness, what happens? This becomes the equator. So now in this case, like we are seeing sometimes, we are seeing that our earth is overhead on Tropic of Cancer. That time we had the summer solstice on 21st June. So how it is overhead? Sun is overhead the Tropic of Cancer. That is because of this tiltness. That's why it is overhead on this particular point. Now in this point, if you see, while studying, we are seeing that on 21st June, what is happening? Tropic of Cancer is receiving this maximum light. So during that time, suppose if we had our Earth surface lies without tiltness, so in that case, what would happen? Suppose here we would have this Earth surface lies without tiltness, and we have our sunlight. So when the sunlight will be coming, so in that case, what will happen? It will be falling equally in the Tropic of Cancer and also in the Tropic of Capricorn. It will be falling equally in the Tropic of Cancer and the Tropic of Capricorn. Okay, but when because of the tiltness, what it is happening? Because of the tiltness, what it is happening? Now sun rays is directly overhead this particular point. Okay, sun is directly overhead this particular Tropic of Cancer area. So in that case, what is happening? That here these particular points are receiving the maximum sunlight. Okay, and since we have this cycle of illumination over here, and this we have the equator. Okay, sorry, this is a circular. Why it is happening? Because see here, now see, Earth is rotating on its parts. So here what is happening? Like it is rotating on its parts. So these parts, these pole parts, what is happening? These pole parts, it is not moving anywhere. Okay, it is moving on this plane on itself, right? Where this particular part, if we mark this as 1 and this as 2, so what is happening? Because of the rotation, this particular one part comes this side. Okay, this particular one part will come this side, and this here you will have the one, and here we have the second part. So it, because that is happening, that day and night changes happening, and that is happening because of this rotation. Whereas if you see in the pole part, what is happening? In the pole part, it is rotating on its axis itself. Okay, it is not moving here and there. So during the summer solstice, what is it will happening? During the summer time, if you see, that time we will be having the day in the North Pole. Okay, in the polar side, in the North Pole side, you will be having the full day. Why will be having? Because this particular part will be on its own place itself. Okay, so there we have the 6 months day. Okay, and that time this South Pole will be having the 6 months night. Now when this sunlight will be falling on the Tropic of Capricorn area, that time this particular part will be having the 6 months day, and here in the North Pole will be having the 6 months night. So now in this point, we must know that because of the tiltness only we have summer solstice, all these things, and because of tiltness only this particular sunlight is falling directly overhead on this Tropic of Cancer. And suppose if there would not have been any tiltness, so in that case what would happen? The sun's rays, it will be falling down equally over the North Pole and the South Pole. Okay, it will be falling equally. So this particular phenomena you all must remember. So that was regarding the rotation. Okay, and in this particular point, already we saw that our Earth, the shape of the Earth is in the geoid shape. Okay, and some also they say that as the oblate spheroid. Okay, oblate spheroid. So that is the Earth is slightly flattened at the poles. So this part also we saw that while studying the concept, we saw that Earth is slightly flattened at its poles. Means what? At this particular part, it is at both the north and the south poles, it is slightly flattened. Okay, and bulge at the equatorial region. The radius of the equator is larger than the poles due to the long-term effects of the Earth's rotation. Okay, so here what happens? The speed of rotation and hence the centrifugal force is greater at the equator. So remember that centrifugal force is greater at the equator rather than the poles. So here speed of rotation is what? Speed of rotation is greater at the poles. Okay, so remember this particular point also. So now in these particular points, see here, since the speed is greater and also we saw because of the speed what is happening, the centrifugal force is also greater at the equator than the poles. Now in this particular phenomena also we must know that the gravitational force is not same at different latitude on its surface. Okay, gravitational force is not same. So it is what? It is greater near the poles. So remember this, note down this particular point. It is greater, the gravitational force is greater near the poles and less at the equator. Near the poles and less at the equator. Remember that? And this is happening why? Because the poles are closer to the center due to the equatorial bulge. Okay. Why it is happening? The poles are closer to the center due to the equatorial bulge and thus have a stronger gravitational field. Okay. Now, if you all would have seen, if you all would have known earlier, like the temperature falls as we move from equator towards the poles. So why it is happening? Because of one reason, because of this also, because of tiltness also. So what is happening? Because of tiltness, what is happening? It is reaching here and directly over it. But here in this side, what is happening? We are having in the pole side, what is happening? We are having a slanting rays. So in case of slanting rays, now sunlight will be not reaching. So like it will be reaching also means what? In the less amount. That heat division will take place. So what? The temperature falls down as we move from equator towards the poles. So the temperature falls at the surface of the earth as ones move away from the equator towards the poles. So this we have studied. And this is because what? This is because of the geoid shape of the earth and the position of the sun related to the earth. So position of the sun relative to the earth. Okay, and also because of the geoid shape. Now the speed of rotation of the earth is greater at equator than at the poles. This we saw. So thus the centrifugal force is greater at the equator. And as the centrifugals and the gravitational force are counteracting forces, so they means what? They are acting in the opposite direction. Okay. So in that case, how we can say because of the centrifugal force, because of the maximum centrifugal force, the gravitational force is what? Like a centrifugal force and the gravitational force are what? They are opposite to each other. Means what? Centrifugal force is maximum at equator. But whereas if we see the gravitational force, it is maximum at the poles. Okay. So they are counteracting forces. So remember that centrifugal and the gravitational force are counteracting forces. Now we come to the part of the revolution. So now in this revolution, we must know that the earth spins on its axis. It also orbits or revolves around the sun. Okay. When it is orbiting or the revolving around the sun, so that is what? That is the revolution. So that part also we saw. The plane in which the earth revolves around the sun is called what? Orbital plane. Okay. The plane in which the earth revolves around the sun, okay, lies plane. So this plane you are like while studying about this one, see. So on this plane it is revolving. Okay. So this particular plane is what? Is called a what? Orbital plane, or we call it as the elliptic. Okay. Most large objects in orbit around the sun lie near the plane of the Earth's orbit, known as the elliptic. Okay, and then planets are close to the elliptic, whereas comets are and the Kuiper belt objects are greater angles to it. Okay, so leave over this point. Just remember that. What do you mean by the revolution? So what? It is revolving around the sun. So that is what? Revolution. Okay. So now we saw that that Earth day and night changes. Day and night changes is happening because of what? Because of the rotation. This part we saw. Then now regarding the revolution, if you see the seasonal changes, okay, like we have the summer season, winter season, all these changes we have, that is because of the revolution. Okay, that is happening because of the revolution. And why all these changes we are happening? Like see here, our Earth is, we know that, suppose if here we have the sun. Okay, here we are having the sun, and we know that our Earth is rotating on its axis and also revolving around the sun. So now in that case, what will happening? Suppose if this particular, now you can see a map, this particular part is receiving the maximum amount of light. So in this case, what is happening? This part is having the high heat. Okay. Now this part, now because of that, what will happen? Because of this like heatness, because of the heating of the earth surface, so there what will happen, that surface also will be heated, means what? There will be the like summer season type. Okay. Similarly, if you see in this particular part, this part what will happen? This part we have the winter season type. So lies what? Because of the revolution also it is having changes. Now at this particular point, now this part will be getting the light. So this part will be having the summer season and this part will be having the winter season. Similarly lies. So in this way also, like that is because of the seasonal changes that we have, that is happening because of the revolution. So seasonal change happens because of the revolution, and also there is one more point that happens because of the inclination. Inclination. Okay, that is what? That is means what? That is tiltness. Okay. So seasonal change happens. Remember that in the UPSC. Remember that revolution is okay. Because of the revolution, seasonal change happens. So in AFCAT exams, they won't go that much deep. But for in the UPSC exams, they might, if they give the statement based questions, so they might go deep and they might give this also as the options. Okay. So remember that seasonal changes happens because of the revolution and also because of the inclination. Okay. And this both should occur. Then only will have the seasonal change. So remember this particular point. Now the revolution we are studying, it takes 365 1 by 4 days. That means what? 365 days and 6 hours to have a one revolution around the sun. Okay, and that 6 hours we are counting after 4 years, and then we are telling that there will be a 366 days after 4 years. Okay, so we have the leap year. So this part we have studied, and in that case, what is happening? The February month is having the 29 days instead of the 28 days. Okay. So now in this point, also we'll see that all those summer solstice, winter solstice, all these occurrence happens. Okay. So now if you come to this part, now see here. Now in this part, what happens? This line is what? This line, if you see, this is the cycle of illumination. Okay. Now here in this case, what happens? Here again, this particular line becomes the cycle of illumination. Okay, sorry, not this geographical north and south. Okay, this line was geographical north and south, and here again we have the geographical north and south, and here we have this line as the circle of illumination, and this is the north and south. Okay, so now in this also we have this geographical north and south. Now you see in this particular map. Okay, in this particular diagram you see here, we know that our Earth is rotating, also revolving around the sun. So now in this particular point, can you see now because of tiltness? Okay, because of the tiltness, what it is happening? Because of the tiltness, what it is happening? See here. Because of the tiltness, can you see this? Since we have this equator over this area, so this will be the Tropic of Capricorn. So this will be what? Tropic of Capricorn. So now in this particular point, Tropic of, can you all see in this diagram? What is happening at this particular Tropic of Capricorn? Tropic of Capricorn. Okay. So regarding this Tropic of Capricorn, if you see, at this particular point, now this particular sunlight is falling directly overhead. Okay. So at this particular point, now sun is falling directly overhead. So now in this case, what is happening? Now in this case, we have this summer season type in this area, in the southern hemisphere. And here the sun rays is falling what? It is falling slanting. Okay. Here we are in the slanting type. So now in the, because of slanting type, what is happening? It will be receiving the less amount of sunlight. Means what? Less amount of heat it will be reducing. It will be having. Okay. See, less amount of sunlight also it will be there. Okay, and here in this case what happens, less amount of heat also will be there. So at this case what happens, here we have the winter season in the northern hemisphere, and here in this particular southern hemisphere we will be having the summer season. Now as it rotates, as it revolves around this particular sun, so here in this case what happens, here when it comes here, so here at this particular point what happens, it receives in this particular point, if we divide this half, so at this particular point we receive the equal amount of sun's light, okay, in the both the hemisphere. So in that case what will happen, we have this equinox. Okay, when do you have the equinox? That equinox we have in the like 23rd September we have. Okay, 23rd September we have the equinox March, and the 23rd September we have the equinox. So now if you see here, now on this particular point, if you see here what it is happening, here this particular hemisphere is receiving equal amount of light. So here in this case what happens, during the equinox we have the 12-hour day and the 12-hour night. Okay, 12-hour day and 12-hour night, and that is happening because of the equinox. Now sun is rotating, sorry, earth is rotating on its axis and it is revolving around the sun, and here we have this like half is getting the full light and half is getting half part of the earth is getting not getting the light. Now when it rotates, now this half part will come here and this half part will be not getting light. So in this case what happens, we have the 12-hour day and the 12-hour night. Okay, and that particular phenomena we call it as the equinox, and we have the equinox twice in a year. One is on 23rd September and the other is on the 21st March. Okay, now when we come to the next point, now you can see here in this diagram. Okay, so now what is happening, now because of the tiltness, okay, this is equator. So because of the tiltness, this earth rays, sorry, sun's rays, it is falling directly overhead on the Tropic of Cancer area. On the Tropic of Cancer area, it is falling directly overhead on the Tropic of Cancer area. So what is happening in this particular point? What is happening here? Since this particular point is receiving the maximum amount of sunlight, and here in this area, this particular areas, what is happening, they are receiving in the slanting type. Okay, they are receiving in the slanting type. So here what will happen, here we'll have the winter season, and in this area we'll have the summer season. Okay, and they remember that during this time, during the summer solstice only, we'll have the 6 months day at the poles. And why it will be having that, we signed the previous part, that this poles particular latitude will be not rotating. Okay, it will be on its surface, on the same place itself. Okay, and so that's why this particular place will be receiving what, it will be receiving 6 months day. Okay, now in this point, now as we saw all these important points, now similarly if you see here these diagrams, so here what happens, here we'll be receiving the equal amount of sunlight. So in this case what happens, there will be again equinox. Okay, so again here we have the 12-hour day and the 12-hour night. Okay, now in this point you all must remember that here, suppose if we have this particular earth, okay, so why it is happening this tiltness, why we are having this changes, so that everything is happening because of the tiltness. So remember this, because of the inclination we have the inclination, and also inclination means what, now that axis has become here, so now earth is rotating on this particular place. Okay, so because of the inclination, and also we have the because of the revolution, the seasonal changes are happening. So remember this particular point. So these are the important points we have seen here. Now if you see here, we have the summer solstice, we have the various phenomena. We have the summer solstice, we have winter solstice. Okay, we have winter solstice. Then also we have the other part, that is the equinox. In that equinox we have the vernal equinox, autumnal equinox. Okay, so in this equinox, like we saw that on 20th March we have one equinox, then on 23rd September we have one equinox. So that also we'll see. So first we'll see the summer solstice. So summer solstice, what happens? Okay, Now in this point, you all remember that we study about the perihelion and the aphelion. Okay, we study about the perihelion and the aphelion. Okay, aphelion. So in this point, what happens? During the aphelions, we know that the sun will be what? Nearer to the Earth's surface. And that happens, that is how much nearer? Means at that time it will be 147 million kilometer. Okay, 147 million kilometer. So now in this point, you all just write down in your notes that sun will be nearer to the Earth's surface in the January month. Okay, in the January month, sun will be nearer to the Earth's surface, and that will be happening on like 4th January or somewhere will be finding the 3rd January. Okay, so remember that in January month the sun will be near to the Earth's surface. Okay, then if you see regarding the farthest away, like perihelion. Okay, perihelion, we saw that sun is how much? At 152 kilometer, 52 million kilometer away from the Earth's surface. Means what? That time it will be the farthest most. So this perihelion, this will have the sun will be away from us, and this particular point it will be happening in the. So this particular point will be happening in the July month. So remember this particular point also. So this in July also, like in the July month also, it will be having like nearby 3rd or the 4th July. Okay. So during that time, what will happen? The sun will be at the farthest distance and sun will be nearest to the Earth's surface during the 3rd or the 4th January. Okay. So remember this particular point. So now we are going to study about the summer solstice. Okay. So on 20th June, remember that when do we have the summer solstice? When do we have the summer solstice? So remember that on 21st June, we have the summer solstice. That means what will be happening on 21st June? On 21st June, this particular sun rays will be falling directly overhead on Tropic of Cancer. It is falling directly overhead. Means what? That time this summer solstice will have in the northern hemisphere. Okay. So in the summer solstice, what will happening? We have in the northern hemisphere. So what we can say, in the southern hemisphere, what will happen? They will be having the winter solstice. Okay. On 21st June. Okay. They will be having the winter solstice. So remember this, lies by using the concept, they will ask suppose if they will ask that in southern hemisphere, when do we have the winter solstice? So remember this particular point. So on 21st June, the northern hemisphere is tilted towards the sun. So this particular point will be tilted towards the sun. So it will be having the summer solstice. And the rays of the sun fall directly on the Tropic of Cancer. So as a result, these areas receive more heat. Okay. So since a large portion of the northern hemisphere is getting light from the sun, and it is somewhere in the regions north of the equator, that in the northern hemisphere we have the summer solstice, and that we have on the 21st June. Okay. So the longest day. So when we have the summer solstice, during the summer solstice, what is happening? During this time, we'll be having the longest day. Okay. We'll be having the longest day and the shortest night. Okay. Remember this particular point. We'll be having the longest day and the shortest night. And remember also that during the winter solstice, what happens? During the winter solstice, we'll be having the shortest day. And longest night. Okay. So remember that summer solstice happens on 21st June in the northern hemisphere. Okay. This happens in northern hemisphere. So remember this point. Then we have the winter solstice. Winter solstice, which we study, that winter solstice we have on 22nd December. We have on 22nd December, and this particular phenomena also in the northern hemisphere. Okay, remember that winter solstice we have on 22nd December, and that is in the northern hemisphere. If they ask regarding southern hemisphere, so remember that on 22nd December, what is happening? They will be having the summer solstice, okay, in southern hemisphere. That phenomena will be what? Vice versa. So remember this particular point. So now in this particular point, we will see this phenomena. So here, the longest day and the shortest night all across the northern hemisphere occurs on the 21st June. At this time in the southern hemisphere, all these conditions are reversed. So that's what we will see. It is the winter season there. Okay, so there we will be having the winter season. And there what will happening? There they have the night will be longer and the days will be shorter. So this position of the earth is called what? Summer solstice. That on 21st June we have this. Okay, so on 20 the position of the earth is called the summer solstice. But for southern hemisphere we have the winter solstice on 21st June. So remember that. During the summer solstice, the whole Arctic region falls within the zone of illumination. So that will be what all day long. Okay. So see here, at the zone of illumination, what happens? At the zone of illumination, suppose now we have this vertical north and south here. Here we have the equator. So now in this case, what will happen? This particular Arctic circle, it will falling down in the zone of illumination. Means what? Here we have the cycle of illumination. So here in this area, we will be receiving the light. Okay. So this is what? This is the zone of illumination. So in that part, what will happen? During the summer solstice, the whole of the Arctic region. So this is what? Arctic region. And here we have the Antarctic region. Okay, that we have seen. So here this particular part will be getting the light. Okay. So during the summer solstice, the whole of the Arctic region falls within the zone of illumination all day long. So remember this point also. Okay. So that was regarding this particular point regarding the summer solstice and winter solstice. Also, we saw that when do we have? We have on the when do we have the winter solstice? We have on the 22nd December. Winter solstice we have on 22nd December, and don't forget to write that is in the northern hemisphere. Okay. Then what happens? Then summer solstice, if you see regarding the southern hemisphere, that will be having on the 22nd December, southern hemisphere. Okay, remember this. Then winter solstice in southern hemisphere, when do we have? Winter solstice in the southern hemisphere, when do we have? We have on 21st June. Okay, that is in the southern hemisphere. Then summer solstice, when do we have? We have on the 21st June in the northern hemisphere. Okay, so remember these points. Okay, now we come about the equinox. So equinox, what is happening? On 21st March and the September 23rd, the direct rays of the sun falls on the equator. Okay. So when it falls, like here we have, so when it falls on the equator directly, okay, at these, suppose if we have lights, okay, so it is falling directly overhead. So in that case, what again? These areas, okay, it will be having the equal days, equal number of hours of days. So like we have the 12 hours day and 12 hours night. So on 24, that will be happening on 21st March and the September 3rd. The direct rays of the sun falls on the equator. At this position, neither of the poles are tilted towards the sun. So the whole earth experiences the equal days and the equal nights. Okay. And this is called an equinox. And this happens on 23rd September. It is autumn season. Okay. On 23rd September, it is autumn season. So that's why we have this autumnal equinox. Okay. So remember this particular point also, like questions can be asked that when do we have the autumnal equinox? So remember that autumnal equinox we have on the 3rd September. And when do we have this spring equinox? When do you have? We have this on 1st March. So here what happens? The seasons after summer and before the beginning of winter in the northern hemisphere. Okay. So there we have the autumnal equinox. Then and the spring season after the winter and before the beginning of summer in the southern hemisphere. So that is what? That is the spring equinox. Okay. And the opposite is the case on the 21st March when it is spring in the northern hemisphere and autumn in the southern hemisphere. So remember this particular point. It is spring in the northern hemisphere on 21st March. Okay. On 21st March, it is spring in the northern hemisphere. Okay. But in the southern hemisphere, what is happening? There we have the autumnal equinox. Okay, and whereas in the regarding this autumnal equinox, if you see this, we have on 23rd September, on 21st March, sorry, 23rd September. Okay, autumnal equinox, and this we have in the northern hemisphere. But during this time on 23rd September, we will be having the spring equinox in the southern hemisphere. Remember this point also. Okay, now in this particular point, there is a question like in the summer season, you all would have seen during the summer season, you all would have seen that what will happen? The sun's rays will be visible to us even like after 5 o'clock, 5:30, 6 o'clock, even that after that also, like when the dawn has started, so that time also you'll be seeing the sun rays. Okay. And that time means what? That time also you'll be seeing the sun rays. And the early morning also you'll be seeing the sun rays early morning. So that is happening because of what? So that is happening because of the refraction. Okay, remember this particular phenomena. It is happening because of the refraction. And why it is happening because of refraction? That phenomena, like how you all can understand, I'll show in this diagram. So here, suppose here we have this particular Earth surface. This is Earth and this is Sun. Okay. So now what is happening? Yes, sun rays are falling down. Okay. And we know that in the atmosphere, we have the various dust particles. We have the various dust particles in the atmosphere. Now in this case, what is happening when the sun will be setting? Okay, so like from this point, from this point, when the sun will be setting, means what? This area will be not getting light. Okay, and this side it will be like here it will be setting, means what? This area will be going to become dark, and this side it will start gaining the light. So in that case, what happens? Even after 5 o'clock or 6 o'clock, we will be seeing the sun rays. Okay, during the summer season. So why it is happening? That is happening because of the refraction. Refraction is what we know that during the refraction, what like reflection, you all would have seen that. Suppose if we have a mirror, okay, so we'll see the same thing. Means what? It will not change its parts. It will not go inside a particular part and it will change its parts. It will reflect back from there itself. Okay. But whereas in the refractions, what we see when this particular part, when it passes through the second medium, the other medium. So what happens? Like suppose if you have some materials over here, now from this it is passing to the other medium. So in that case, what happens? That light bends away. Okay, that light bends away from the normal. But in the reflection, what happens? It will, when it falls on the mirror, okay, and then from that same place it will be reflecting back. Okay, but here in this case, what happens? It bends away from the normal. Okay, so in this case, what happens? So similarly, because of the presence of dust particles in the atmosphere, what happens? This is our Earth surface and this is sun. Okay, now we have some dust particles over here. Okay, now what happens? Now when the sun rays are falling down on these dust particles, now it is going to set. Okay, but what happens when it falls down? So from here, when it enters this medium, or when it enters this medium, so what happens? Now the lights, this particle lights bends away. Okay, so now instead of light, what happens? It will bends away lights. Okay, so that's why during the summer season we'll be seeing the longest day. Means what? That light will be for the longer time. Okay, instead of 12 hours, and the sun's light we might be seeing for the like 14 hours, 15 hours. Okay, so that is happening because of the diffraction. So remember that point. So see here, days are longer than the nights. Okay, days are longer than the nights at equator. Okay, at equator they are saying. That is happening because of why? That is happening if there was no atmosphere, there would be no reflection. Okay, if no atmosphere there, then we will not have the reflection. And because of atmosphere only, we have these dust particles. So and the daytime and the nighttime would be near equal at the equator. Okay, so at least during the equinoxes. So but due to atmosphere, the sun rays get refracted. Okay, due to the atmosphere, presence of the atmosphere, and in the atmosphere we have the dust particles. The sun rays get refracted. So what happens? The bending of light due to the change in density of the medium. Okay, so refraction is what is happening. It is particularly stronger during the morning and the evening time. Okay, so when the sun rays are slanting type. Okay, so even though the actual sun is below the horizon, okay, like we have the horizon over there, even though sun rays is below this horizon, so what happens, this particular, because of presence of the dust particles, it bends. Okay, it bends towards the surfaces of the earth. Okay, so even the actual sun is below the horizon, its apparent image would appear above the horizon. Due to the reflection, this makes the days longer and the nights at the equator. Days longer at the equator. And this particular phenomena, you all will be seeing in the particular part during this particular phenomena, you will be seeing mostly during the summer season. Okay, that time we will have the, like, even the sun has sets. Okay, even the sun has setted. Okay, so that time what will happen? That time we'll even that time also we'll be seeing the sunlight. Okay, so that happens because of the refraction and the atmosphere of the earth. Okay, so now regarding the perihelion and the aphelion we had studied. So this what happens, the earth revolves around the sun in an elliptical orbit with the sun at one of the foci. Okay, so what happens, approximately every lakh years, okay, approximately every lakh years, Earth's orbit path changes from being nearly circular to elliptical. Okay, and that is happening because of the gravitational influences of the other planetary objects, and that is particularly the moon. Okay, so leave over this particular point. Now, if you see the perihelion and the aphelion, already we had seen. In the perihelion, what will happen? The sun will be farther at the farthest distance. Farthest distance. In the aphelion, what will happen? It will be nearest. Okay, and we saw the distance. This time during the farthest, the distance will be how much? 152 million kilometer. And during the aphelion, we have 147 million kilometer. Okay, remember this particular distance also. Okay, the Earth is closest to the Sun at its perihelion, and it is farthest from the Sun at the aphelion. And this closest, it occurs about 2 weeks after the December solstice. Okay, so on the 4th July, is farthest from the Sun. So during this time, what happens? We have the on 4th July. This aphelion means what? This will be the farthest, and perihelion means what? It will be the nearest. Okay, then here the distance will be the 147 million kilometer. Okay, and here we will have the 152. Okay, so don't get confused. So remember this particular point. Okay, so now perihelion is a point in the orbit of a planet at which the planet is closest to the sun. So during the perihelion, the planet is closest to the sun, and that is happening on 3rd January. On 3rd January, the Earth is nearest to the sun. Okay, and about 2 weeks after the December, that will be happening about 2 weeks after the December solstice. Okay, when it is winter in the northern hemisphere. And on 4th July, we have this our Earth's surface away from the sun. Okay, so during that time, what process will be happening? We will have the aphelion. Okay, so remember this particular point. Now, at the perihelion, we saw about 147.1 million kilometer away from the sun. Okay, and during the aphelion position, what will happen? The sun will be away from us by how much kilometer? 152.1 million kilometer away from us. Okay, so the dates when Earth reaches the extreme points on its orbit are not fixed. Okay, so sometimes they will say like on January we saw about the perihelion, or on 4th January. So similarly in the this particular regarding this aphelion also, it will be in the July month. Okay, so here dates are not fixed. Like sometimes we say it as the 4th July or the 3rd July. Okay, so remember this point. So perihelion, the aphelion we have studied. Then amount of energy, that everything also we have studied. Okay, then the duration of season. The elliptical orbit does not affect our weather by affecting the duration of the season, although this effect is not significant. Okay, so this, like summer season and the winter season, how it happens, that everything we have studied, and that happens because of the revolutions. Okay, so that everything we have seen in this particular class. Okay, so now in this particular point, if you see, don't worry about this orbital velocity and all. This is the science part. So leave that point. Now regarding this, some questions is there. Now these questions, if you see, seasons are caused due to. Okay, so seasons are caused due to which region? First is what? The Earth's rotation on its axis. Okay, the Earth's revolution around the Sun in the elliptical manner. Latitudinal position of the revolution of the Earth on a tilted axis. Okay, now since this is a rotation, so we know that seasonal changes happens because of the revolution. Okay, so this option is incorrect. The Earth's revolution around the Sun in the elliptical manner. Now here we have the revolution. But here what is happening? In the other case, we are seeing that it is Sun in the elliptical manner. Okay. So now this revolution, since revolution is there, so okay, we'll leave this point. Okay. Now we'll move to the next option. Latitudinal position of the place. We know that it is not happening because of the latitudinal position of the place. Okay. So this option also goes away. Now if you see in the last option, what happens? Revolution of the Earth on a tilted axis. Okay, revolution of the Earth on a tilted axis. And that everything we studied in this class. So which one will be the correct answer? So this will be the correct answer. Okay. Now next question, if you see here, the shape of the Earth is geoid. The shape of the Earth is geoid shape. Okay. The region that lies between the Tropic of Cancer and the Tropic of Capricorn is called torrid zone. During the heat zones of the Earth, we saw this particular point. The torrid zone lies between the Tropic of Cancer and the Tropic of Capricorn. And the shape of the Earth is geoid. That we saw in this class also, and the earlier classes also we had seen. Okay. Or geoid also, or we call it as the oblate spheroid. Then the temperature decreases from the equator to poles because of the shape of the Earth. So we saw that now what is happening, the surface is how it is like tilted, bulge at equator. Okay, it is bulge at equator, and at poles it is what? Flat type. Okay, it is flat type. So in that case, what is happening? The maximum rays, okay, maximum sunlight is being received by this particular part. Okay, and here it is reaching in what? In slanting type. So that is happening. Why? That is happening because of the tilted only. That is happening because of the shape of the Earth only. Okay, so that's why the temperature is decreasing because of the shape of the Earth. So this is also correct. 2 is also correct, and 1 is also correct. Now fourth we have the North Pole is a latitude. North Pole is a latitude. While studying about the latitude and the latitudinal lines, we saw that how much latitude we have. We have totally 181 latitude. And how much latitudinal lines do we have? We saw that we have 179. Okay. So here what they are talking about the latitude. And we saw that North Pole is a latitude, but it is not a latitudinal lines. Okay. We saw that. So this is also correct. So here all options are correct. Okay. So remember all these points we have discussed here. So this is all about the motions of the Earth. This is all about the motions of the Earth.